Okay, so today we're going to continue looking at scatter plots and observing correlation between two variables on a scatter plot. We've also addressed the least squares regression line and how we can best find that. We have hinted around at something throughout all of this as we went through, and that was something called the residual. And today we're going to continue by addressing exactly what the residual is. A residual is the actual difference between what we're going to observe on the scatter plot and the value that would be predicted by our regression line. Remember, the regression line does not necessarily connect points that are on the scatter plot. It is listing off all of the predicted y values for each possible x. And, what we're going to see is that it's going to miss the actual points on the scatter plot actually most of the time. So the residuals are going to be the distances between those actual points and the line itself. Now, the way we find the residual for any given point is we find the observed y-coordinate and then we subtract the predicted y-coordinate, that value that we would get when we plugged x into the least squares regression line. Once you find the residual of all the points, if you were to add them up, you should get a sum of 0. And the reason for this is because the line where all the predicted y values lie is the middle or the balancing area of all of the points. Remember that we have minimized the distance from all of the individual points to the line as best as we possibly could. So when we look at residuals, the sum of all of them is going to be 0. Once we calculate all the residuals for a set of data, we can observe something we call the residual plot, which is basically a scatter plot of all of the residual data. Residual plots are often used to assess the fit of a regression line with a set of data. Now, after we look at how to form a residual plot, we can make a decision as to whether that data that we're looking at is a good fit for a linear set of or linear regression. You can't always use a regression line if you don't have what we call linear data. So that would be a good way, or the residual plot, is a good way to assess whether that data is linear in nature, or if maybe it's curved, or there are some other issues with it. So continuing on, a residual plot is, like I said, a scatter plot of the residual values with the explanatory values. We do use the x coordinates that are listed, and then we plot the residual for each of the y coordinates. Provided the regression line fits the data well, we should see in the residual plot, we should notice that there is a consistent scatter about the midline with no specific pattern. So what we're looking for when we observe a residual plot is a nice clear balance of just random points on both sides of the midline of the graph. The regression line does not fit well if we observe a situation where we have a curved pattern in the residual plot. Sometimes you get something that's an obvious curved pattern, and that would tell you that the data is curved in nature and a line is not going to fit it. Sometimes we'll also get what we call a cone shape, or something where the residual points are spread out really far at one side of the graph and maybe not spread out as much on the other side of the graph. It kind of creates a cone shape. And that would indicate to us that certain points of the line are not as strong as a predictor as other points are. So that'll be something that we analyze a little bit further as we progress through this. We'll also notice specific individuals with large residuals. These could be outliers. There could be some issues with them that are creating some problems in the residual plot, or in the least squares regression that we need to be made aware of. So looking at a residual plot often can point out those specific points. We can also identify individuals in the extreme X direction. So again, if we're finding individuals that have a large residual or are lying in the extreme X direction, usually we would consider those points to be outliers. And we always want to be aware of our outliers in a set of data. In some cases, we might want to eliminate them from the set of data because of certain circumstances. Other cases, we might just want to be aware of what they are and why maybe they're happening. So those are some simple facts about residuals. Now we're going to look at a quick example of how to make a residual plot. What we're going to do is, here's some data based on a problem from your book, actually, where the age of children is given, and this is in months, and the amount of time, the age that they were at when their first word was spoken. And then there are a Gessel adaptive score, which is a social measure that's used to judge a child's social interactive ability. I'm not going to give you all the details of that, of course, but basically all we're going to do right now is analyze the relationship between these two. So the first thing we're going to do is we're going to compute the least squares regression line, and then we're going to find the residuals of each. And then we're going to make a residual plot of the data, and we're going to acknowledge our findings. So what I want you to do at this time is grab your calculator, and hopefully by this point you're pretty well versed in entering the data from a problem into the calculator list and gathering that data up to make a scatter plot. We're going to do that now, and then we're going to take a quick look at forming the regression line and using that to get the residuals. So with that said, I want you to maybe pause the video right here and enter this data into your calculator. Okay, so as you can see, I've taken the time to go ahead and enter these pieces of data in the calculator as well. And you can see I've got my list here. All of the data was put into list 1 and list 2. So what we're going to do now, first let's, as we always say, we want to get a bird's eye view of the data on a scatter plot. So we're going to go ahead and look at the scatter plot. So let's look at our stat plot menu, and I'm going to go ahead and set this up for a scatter plot using list 1 and list 2. And as we do that, again, hopefully you're pretty familiar with this process. I'm going to zoom to my data, which would be zoom 9, and we get a good, nice picture of our scatter plot. You can see that the data seems to be somewhat linear in nature, and it seems to have a negative association. Hopefully you're able to see that. I see a nice trend moving downward through here, and we're going to now find the least squares regression line and look at that on the graph. So let's go ahead and do that. If you've seen my other video on doing regression with the TI-84, hopefully you remember. We're going to go Stat, we're going to go to the Calc menu, and then we're going to move down to option 8, which is the linear regression. And we'll do this for list 1, and we'll make our Y list, list 2, of course. We're going to store the regression equation in Y1. And I am going through this fast. I apologize, but again, there is another video on how to do this. I'll talk you through all the steps if you are getting a little lost. Oh, I don't have my diagnostics on, so did not get the R measurement, but we get a nice equation there. We have A is 109.8738 and B is negative 1.126 or 1.270. So our equation would be y hat equals 109.8738 minus 1.1270. So if we look at that on the graph, you will see, the calculator is going to graph it out for us, that we get this nice looking little graph. Okay, so now we're going to look at the actual residuals. Now keep in mind, I'll go ahead and show you, we do have our regression equation stored in Y1. Now that's going to come into play here. This is a very important thing to make sure you have there. If we don't have this in Y1, or at least one of the Y functions, we're going to have an issue in finding the residual. So what we're going to do is use that. We're going to go to Stat, Edit, and now we're going to go over to List 3. Now we want List 3 to be all of the residuals for each of these 21 points. So the way we're going to do that is we're going to highlight L3 and press Enter. So this will get us the opportunity to make an entire list of values in L3. Now, based on what we know, the residual is Y, the observed Y, minus the predicted Y. And the way we get our observed Y, of course, is by looking at the values we have in list 2. So we're going to say list 2 minus our predicted Y's. Now we get our predicted Y's by taking all of these X values in list 1 and plugging them into the X coordinate or the X value in our regression equation, which is in Y1. So the way we enter this is we go, pay close attention, we go list 2, which we already have in, minus Y1, or the function Y1, of list 1. Now what this is telling the calculator to do, real quickly, is take all the values in list 1 and plug them in to the function Y1 and get a value. Now that's pretty much like evaluating a function. If you go back to your algebra classes and pre-calculus where you had a function f of x and you plugged an x value into it and it gave you a specific value. That's what we're doing here. This is our function y1 and we're going to plug the values from list 1 into that. And after we get those values, we're going to subtract them from list 2. So as I enter this, you will see that we get a nice list of residuals for every single point. Now what that is telling you is how far each one of these points is from the line. Again, going back to this graph, the first residual I believe was 2 point something or other. That's how far this point is from the graph. Now these points above the graph are going to give us a positive residual value. The values below the graph line is going to produce a negative residual. So again, anytime we see a positive residual, it's indicating a point that is above the line, and if we say a negative residual value, it's a point that is below the line. So let's continue going back to our stat plot or our stats. You can see this point had a positive residual of 2.031. There was a negative residual, meaning this point, 2671, was below our predicted Y values, our line, by 9.572 units, and so on. I won't bore you by going through every individual point, but that's what we're talking about here. So if we want to make a residual plot, we are going to graph the residual values with our X coordinates. So we're going to take our X coordinates in list 1, we're going to take our residual values in list 3, and we're going to make a residual plot. So the way we do that is we set up our stat plot. We're going to use the same scatter plot we've been using. However, our Y values are no longer going to be in list 2. They are going to be in list 3, where I just figured out all of the residuals. So all I need to do is change that, and I have an X list of list 1, which is my X values, or my explanatory variables, and my Y list is now going to be the residuals for each point. So we do that, and we go to look at the graph. That's the old graph. Don't worry about it. Notice none of the points are there anymore. So we're going to zoom to 9, and you can see our residual plot for this data. Now, what we're looking for in the residual plot is a nice balanced spread of points along the midline, and this, of course, being the midline here in the middle of the graph. Now, you'll notice there is one point that is a vertical outlier that we see up here, one point well above the midline, and we see another point out here on the far right that is an outlier in the horizontal direction. We would want to be aware of both of those points, and in fact, you might want to go back to the data and identify what those specific points were. But again, this is how we make a residual plot, and it gives us a good assessment of how the line is missing the data in different areas. So there is your residual plot and the method for doing that. So talking about what we call influential observations, we can easily identify these on the residual plot. An outlier, any point lying well outside of the general pattern of the other observations, is a type of observation that will have a strong influence on the least squares regression line. It can have a big impact on the slope of that line. It can even change the y-intercept around. It can have a big effect on a lot of things. And these can come either vertically or horizontally. Points that are outliers in either the x direction or the y direction of the residual plot are points that are having a strong influence on the least squares regression line. You really need to be aware of these. If we go back and look at our calculator, we can see that there were a couple points here that do have a strong influence on what is going on in this data. And we can see, as we mentioned earlier, we do have a vertical outlier up here, and we have a horizontal outlier out here. So we would want to identify those specific points and possibly consider taking them out of the data to look at the rest of the data as it goes. In both cases, removal of these points should be considered. Like I just said, we might want to take those points out and take a better look at what's going on in the data. Remember, of course, if we look at an outlier in the x direction, it does not necessarily have to have a large residual. If you go back and look at that horizontal outlier, the residual for that point was very small. It was just above the midline. However, it was far removed from all of the other points on the residual plot, so it would be a point that is having a strong effect on the data, and we might want to consider moving that out. A possible thing to consider would be to go back and take those pieces of data out after you identify what they are, and possibly take a look at what happens to the data at that point. So I'll leave you with that. Just in case you were wondering, we do have a homework assignment that is related to this. I would like for you to complete the problems on page 192 that are listed here, and we'll take a good look at that the next time we come back to class. Have a good day.